Alright, so guys, we have, when you have a squared term, that tells you it's quadratic, that little 2. You might want to write this down. I'm going to give you just a quick strategy session on how to solve these. We're not too far from getting into solving quadratics in our geometry, so I just want to keep reviewing it. First thing to remember is that standard form for a quadratic, and I'm going to add the equal 0 part. So generally it's a good idea to get this equal to 0 when you have a quadratic. So they're really only for geometry. We're not really going to do quadratic formula. So I'm going to show you the 2 strategies that we will use by far the most. And they both depend on having, either having or not having that bx term, that term that has just x, or in this case r. So if you have this term, and you might have to rearrange to see it. If that's a yes, then you're going to star factor to solve, which is what we'll do here. If you don't have that, then you're going to square root. And I don't think we've done an example of that yet, but star factor, or you can sometimes just GCF. It depends on the problem. So if there's not a C term, you can GCF. So maybe I'll add that if no C term. Okay, but it really depends on this initial analysis of whether or not bx is present, because you can't square root if bx is. And so when we look here, I see this negative 16r. So this is the bx term. So we need to star factor. So our first step will be to get it equal to 0. Okay, and then we'll set up our star. And to do that, remember we're multiplying a times c to put in the top section, b goes in the bottom, and then a on the sides, on the top of the sides. So a times c is 3 times negative 12, which is negative 36. And then b in this one is negative 16, a is 3. Sometimes I tell students to go identify a, b, and c. Like just make a little list, A, B, C. And if that helps you, then definitely do that. Alright, so we're looking for factors, or numbers that multiply to make negative 36, but add up to negative 16.
2, negative 18.
Awesome, Mason, good job, thank you. Okay, so he's talking about this. This is a little tip. I'm going to write the 2 here. And then he said negative 18. B, well, the sign of b will always match the sign of the bigger number. Always. So if b is negative, then your bigger number needs to be negative, and then vice versa for positive. Okay, this side cannot be reduced, so I'm circling it to say let's go ahead and put it down here ready to go. And then this side can be reduced, and so we need to divide both by 3, and we'll get 1 over negative 6. So 1x minus 6. Remember, the top number goes with x, and the bottom number you just write with its sign. Okay, so if you follow our work down, this is still equal to 0 because we're solving. Okay. So that's factoring. If this was just an algebra class, we would be done if I just said factor. But we want to know what these answers are, like what actually makes this be 0. So this is where we split. So 0 times something is 0, or something times 0. One of these is 0, or maybe both. So we split them and figure out where that occurs. Here's what I mean. Set that equal to 0, so we can figure out what x value gives it 0 value. So how do we solve that little quick equation?
Plus 2.
Yeah, just add 2. It's basically just regular solving at this point. So 3x equals 2, and then divide by 3, and we'll get x equals 2/3. So that's one of our potential answers. Over here it's a lot faster, and if you haven't already, you'll get to where you can just read these and say, hey, that's 6. Okay? Because if I add 6 to both sides, then I get x equals 6. So there's the two possible answers that we'll have for this quadratic.
Shouldn't it be 3x plus 2?
Yes, it should. Yes, it should. Thank you. Plus 2 minus 2, and that'll be a negative. Let's see if I can squeeze that in. Negative. Nope. Negative 2/3. Okay. Thank you, Isaac. Good job for catching that. Okay, so negative 2/3 and 6. Now, in geometry, the negative answer will often be one that we have to kick out because it will make a side length negative or an angle negative, which we can't have. So even though we solve for two answers in algebra, just keep an eye out for ones that don't work. How'd you do on that? You feel like you're getting pretty smooth at this process? Okay. Now we'll look at one of these square root kind eventually. They're actually easier, usually a little bit faster. All right, any questions on this homework? Any of them that gave you trouble? Okay, let's go ahead and check. I'll show you the answers starting at 14, but number 12 is easier to just look at. All right, so remember this is all about perpendicular and angle bisectors. So there's some kind of error in here, and he concluded that AB equals 2BC. In other words, this length is twice BC. Well, let's see where he went wrong. It says EB is the perpendicular bisector of AD. Yesterday we talked through how we can read the pictures, the images, to tell us if we have enough information. So, is this a correct conclusion? Is EB actually a perpendicular bisector?
Yes.
Okay. Because we see the 90, that's perpendicular, and then these tell us that it's a bisector. Because if those two aren't congruent, then it's not splitting that in half. Okay, because of that, we can conclude that this is true. AB and BD are congruent. We know that's a fact. So far, he's on the right track. Okay, angle BEC is congruent to DEC. That was given up here with those little arc marks. So BC. Okay. So this little length and that little length. Can we conclude that? Was that part of either the perpendicular bisector theorem or angle bisector theorem? I'll just give you a reminder. Perpendicular bisector pictures are some version of this. Okay? Do we have that with this line EC? No, because it's not at a 90, right? And I know my picture's jammed up now, so I'll move that. There's no 90 right here at the C, so it's not the perpendicular bisector. And then angle bisector pictures usually look something like this. I'm going to draw that a little slightly different. Starting over. The 90s are out there. There we go. And then those two. Okay, so do we have a 90 here and here? That's what it would take for an angle bisector. And if those are 90 and if these angles are congruent, then those two lengths are congruent. So we do have the angles marked, but note down here, we're not talking about it being equidistant from the two sides. So this is the step that went wrong. From there, his argument is okay, but that was an incorrect conclusion because it has no proof in theorems. Okay, the rest of the problems we'll just check here. So number 14 was 22. Number 15, 3.5. Number 16, 21. 17, 6.6. 18, 42 degrees. 19, 8.1. And 20 was 31. Good job. I like it. Any of those that we'd like to use, or to do, I mean? Any questions on any of them? Okay. So perpendicular and angle bisectors, hopefully doing okay and not too bad of a concept. Anything that you'd like to ask about before we move to the next thing? Okay. All right. That is giant. It's too big. So next topic. You'll definitely want a calculator for this one. I think would be a good recommendation. So this section is erase for those. This section is very formulaic, meaning I'm going to give you two formulas that you can use, but there's some algebra that we'll review a little bit of. And you can see it's midpoint and distance, so we have a formula for each one. And anytime you have a formula, it's basically write it down, plug the numbers in, and solve. It's pretty routine. What do you think midpoint means? Yeah, finally an actually descriptive word. It's the middle of a line, right? Midpoint. So very similar to a bisector. Now, I don't know that anybody would do this, but let's talk about what this is kind of framing. So we're decorating a living room and wants to hang a picture at the center of the back wall. So I'm not sure which one that is. There's the door. Would you guys ever do this? Would you draw a floor plan and center it perfectly? No? Okay. Anyway, how would you do it though if you wanted to center your picture perfectly halfway? Any thoughts on that? Maybe it's your bedroom. I want that picture, that poster, that bulletin board or whatever right in the middle of the wall. How would you do that? Yeah, I did. Okay, so yeah, like let's say we have this big wall here, we want something right in the middle. Probably this whiteboard would be, or the Promethean would be. So find the length and then divide it in half. That would give you the center, and then you can just match the center and do that with your Promethean. Early on, when my wife and I were first married, we wanted to rearrange our furniture without having to move everything because it was a pain. So I actually did this, but I actually made a little scale model of our living room with dimensions and cut out scale models of all our couches and the TV stand and all that. So we could just like move it around and figure out how it was going to fit and then move it only once, and it was kind of fun. Kind of nerdy, but it worked. Are you going to do that? No. Alright, midpoint. We actually have a process for doing this. So grab your notes. I'm going to give you a concept real quick. Let's see what the next one is. You don't need to, you can write this obviously if you want to, but in our notes I'll show you a slightly different method. So first thing that this is it's slightly different from what we've been doing because you can see this looks like an algebra graph. Like we have points on a coordinate grid and we have XY coordinates called out, and so we're kind of back to that a little bit. In fact, a lot of times you won't even have the graph. It'll just be the 2 points. So, and you can do this just fine with that. Guys, here's the concept of midpoint. I'll tell you the formula after we kind of think through this. So from point A to point B, how far down did we go? It started at at 2, and then got down to -2. So how far down did we go?
4.
Yeah, so this length is 4. And it's down 4, okay? But it's 4. So sign doesn't totally matter if you're going to use the formula, but graphically it's kind of important. Alright, and then how about to the right, how far did we go? From -3 to +4.
7.
Yeah, so we went to the right 7. Okay, so the concept of midpoint is basically what Isaac said. Find halfway. The only difference is when it's diagonal, we have to find the halfway point going both directions, so vertically and horizontally. And then whatever that is our midpoint. So we know we went down 4, so halfway would be down 2. Okay? But our coordinate is not -2, it's down 2 from +2, which is what? Okay, so it's down 2 to the midpoint. So we know that our y coordinate will be on the x-axis. And then to the right, it's half of the distance, so half of 7 is what? 3.5, okay? So we're going from A, 3.5 to the right, 3.5 this way, okay? And so what coordinate from A at -3, what coordinate is 3.5 to the right?
5.
Yeah, it's 0.5. So our midpoint would be right here. Now my arrows are off a little, but that's the concept. Okay? So 3.5 over and 2 down gets us to 0.5 and 0. So graphically, it's not bad. You can just kind of think through it. But it is kind of helpful if I don't give you a graph to be able to just plug points in. So I'm going to show you that formula and then show you how we can twist it a little bit by asking a different question in terms of solving. Okay, so first, let's define this. So the middle point of a segment it bisects the segment. In other words, this is a point instead of a line, but it does the same thing to the segment as a bisector. It splits it in half. So we'll see how we can use that to solve, not just for the point, but for also for lengths of lines. So for this, let's draw a little graph. And put some line on here, and we're going to call these, what we call these end points, we're going to call A and B. And then we'll call the center, or the midpoint, let's call it point M. So draw it so that M looks roughly halfway in between. Okay. Also, just to be clear, we're talking about X and Y axis, like these are coordinate points. So I want you to mark on the x-axis that this is the x coordinate of the midpoint, and this is the y coordinate of the midpoint, so that we know our notation when we go to write our equation down. So basically all we're going to do, and we'll go back and look at the example we just saw on the graph. So for the x coordinate of the midpoint, and we'll just write this maybe once, x coordinate of midpoint, so this isn't part of the formula, this is a description. Anyway, x coordinate of the midpoint is just the coordinates, which means add them up and divide by 2. So average them. I'll show you how we did that, even though we were just looking at a graph. So add the two endpoint x's and divide by 2. And then what about the y coordinate? What do you think?
Add the y coordinates.
Yeah.
Divide by 2.
Yeah, same thing. So y coordinate of the midpoint is just adding the y coordinates of the endpoints, dividing by 2 because there's 2 of them. Guys, I'm writing the A's and B's and the M's actually too down below. It's called a subscript. So it's a version of notation or organization, so that I know this is the x coordinate of point A, which is one of the endpoints. So if you want to clarify that, XA, XB, Y, actually let's do it a little bit more. X sub A we say, Y sub A, and X sub B, comma, Y sub B are the coordinates of the endpoints. Just so you have some clarification there. Okay? And then one last thing. This is important. Give the point, which is an XY coordinate pair of the midpoint. Don't keep your answers separate, because we're actually talking about a point in space, so we need to give it as an XY coordinate pair. So that's all kind of the formula, the idea behind this. Let me know when you're ready to go back and look at that graph. So I just want to show you, we thought through it graphically, but for the x's, excuse me, we have our formula. And look what happens. XA, what was the x coordinate of the A endpoint? What was it? It was -3, right? So XA, YA, XB, YB. Okay, so -3 plus 4 over 2, which is -3 plus 4 is 1, so that's just 1/2. And we said 0.5, but that's the same thing. Okay, and then the y coordinate of the midpoint, YA, that was 2, YB plus -2, so that is 0. 2 plus -2 is 0. Okay, and then we give our coordinates, like I did up there, as a coordinate pair, which was 1/2, 0. Okay? So I am fine if you want to do this either way. If I have a lot of graph paper, if I just give you 2 points like this, and I say find the midpoint, and there's just 2 coordinates or 2 points, and like you don't have a graph to look at, feel free to get graph paper, plot them on there, and figure out where the midpoint is. Okay? Or it's also pretty quick to just write the formula and do it with your calculator in 30 seconds or so. I will tell you, if you look at this part B problem, this would be a little bit of a pain to do on graph paper though. Do you agree? Because it's got these decimals, these partial coordinates. Okay? So I'm going to give you 5 minutes to do these two. And again, let me know if you want graph paper. And then we're going to twist this a little before we do distance. Okay, so let's use the formula, and then on this one I'll use the graph just to show the concept. So we know the midpoint is just the average of the endpoint coordinates. So add up, divide by 2. So midpoint x is -2 plus 8 over 2. And so that's 6 over 2, which is 3. And then same thing for the y. This time I'm just going to assume you can change these x's to y's. So that will be 5 plus -12 over 2. So this is -7 over 2, which is -3.5. And if we write this as a point, we get 3 and -3.5. Okay, on the graph, let's plot it. So -2 and 5. And then 8 and -12. I don't know if I got down there all the way. Close enough. Okay, there's our points and our line. Okay, so how far did we go from 5 down to -12? 17. And so we have to think like, what's half of that? Well, that's 8.5. So we're going down 8.5 from 5. So we go 1, 2, 3, 4, 5, 6, 7, 8.5. So somewhere on this line is our y coordinate. And then from -2 over to 8, how far over did we go? -2 to 8 was 10, and so if we split that in half, now we're going over 5. Went too far. So 1, 2, 3, 4, 5. So somewhere on this line. Okay, and then we just go to where those intersect. There's our midpoint. And we're at 3, -3.5. So that's kind of the graphical idea. It's a little bit weird when it's decimal, so that's why I didn't put a graph for the second one, because this would be awkward to graph on a regular graph. But if we want to do it with the formula, it's really not any different than this one. So the midpoint x coordinate is 2.5 plus -6.2 over 2. Y coordinate of the midpoint, -7 plus -3.8 over 2. And then this is why I said it's nice to have a calculator. I will caution you, don't put just divided by 2. Why not? Yeah, like PEMDAS says, go ahead and divide this first and then add it to 2.5. So that's not the correct order of operations. But you could punch this in, enter, and then say divided by 2. That's okay. Or you could do parentheses, 2.5 plus -6.2, parentheses, and then divided by 2. Just be careful that you're getting the correct order of operations. So that one was -1.85, and then 7 and -3.8. is 1.6. Okay. Don't forget to write it as a point. But again, like those numbers would be weird to graph, and I don't think you could do it with a graph. Ah, did I add it wrong? Yep, sure did. I need to quit talking so much about stuff when I'm trying to type. Negative. So negative 5.4. Thanks for catching these things. Alright, how'd you do on either of those? Yeah? Yeah. Okay, here's a twist on this. I don't know if I have a slide, but no. Let me give you a twist just in words. Let's put this in your notes as an example. I think those kind are probably easy enough that you don't necessarily need an example specifically in your notes, but this kind can be a little tricky. So we'll call this midpoint to endpoint. It's the same concept, just with a twist on what we're solving for. So, segment AB has a midpoint at 3, 4. If A is at, let's say, -2, -1, where is B? Okay, take a second to write that and start thinking about what we're actually asking. If you read carefully, I have given you one endpoint and now the midpoint, and I'm asking where is the other end. Okay? So remember, segment AB is the endpoint. So you can sketch a graph. And by sketch, it doesn't have to be perfectly accurate. So A is -1. And then M this time is here. That is M. So we have that much of our line. We need to extrapolate out here and find B. We don't know the coordinates of B out there. Do you see the twist now? Which means we're either plugging stuff in a different place in our formula, or we're thinking through this a little differently. I'm going to tell you two ways, and you can pick your way. I don't really care. Just whichever one works. The first method I think is usually faster. So count to midpoint, then the same distance to the other end. If it's not decimals, this is the way I do it. If there's decimals involved, you have to use the formula. So, how far did we go from A to the midpoint? X direction. So remember, it starts at -2 and it goes to 3. So how far in the X direction did we go? 5. So we went 5 to the right, and how far did we go up from 5. -1 to 4? 5. Okay, up 5 also. So do you see how we can just keep that same pattern and do it again? So we need to go now over 5 and up 5. So where would the coordinates of B be?
8, 9.
Okay, so we go from the midpoint. So actually let me write that first. From the midpoint, B is up or over, let's be specific and say right 5. Right 5 and up 5. So B is
8.
midpoint is at 8, 9. Good job, Parker, thanks. Okay? That's the easy and fast way if there's whole numbers involved, which will often be true. Okay, second method. If I'm going to shorthand this, it's not perfect English. So if decimals or preference, like if you just would rather do it this way, use the formula with M with the midpoint known. And it just depends on your taste in terms of how you like to do math. So here's what I mean. For this method, we're going to use the formula, which means write it down. And what do I know in here? Do I know both endpoints?
Yes.
No, I don't. Right? I'm given a midpoint and an endpoint. So where does the midpoint coordinate go? It goes in for xm, right? Okay, so the x coordinate of the midpoint is 3. And what else do we know?
XA.
We know the coordinate of a, so it is -2. So this is more of an algebraic approach. And then just solve that equation. This is partially why we reviewed solving with fractions. How do I get rid of the 2 in the denominator? Solve for x. Yeah, just multiply by 2, right? It's just the basic algebra skills of getting rid of fractions. So we get 6 equals -2 plus xb. Add xb, and we get 8 for xb. So that's the very logical, very algebraic plug-in, solve through. Again, if I give you one with decimals, you pretty much have to do it this way. Maybe, depending on what decimals I give you. Okay? And then same thing for the y coordinate. Will you mind unlocking that? Just twist the little knob and then pull the handle down. And it should pop out. Yeah, thanks. Okay, next one. So y midpoint, again, the a plus b average. Again, we know the y coordinate of the midpoint, so we know that the y coordinate is 4, and the end point is -1. Okay, multiply by 2. That's going to be consistent. You will always, yeah, I said yeah. Yeah, sorry. Okay, and then 8 equals -1 plus yb. Add your 1, and we get 9. So the multiply by 2 part, it will be the same every time because we're always dividing by 2. So you have 2 methods. Being able to do both, I think you'll find that you have a preference in terms of which one that you do. Any questions on that? Okay, let's give you one to try. And in terms of saving time, I'm just going to write them in here. So conceptual example, because we're not writing a bunch of words. Okay, so I need the coordinates of A. I'm going to give you 3 minutes. If you're going to do the graphic method, I would definitely recommend just sketching. So we know that 1425 is somewhere way out here. 27 is somewhere along the way. And then A, so if we know those connect, and then A's got to be down here somewhere. So we're looking probably at 2 negative coordinates, but we can check that. Okay, so again, graphically, how far from B to the midpoint? So how far down did we go from 25 to 7? 18. Okay, it went down 18. And then over, this time to the left, because sign is huge if you're going to do this method. You got to keep track of sign. So from 14 down to 2 is 12 to the left, right? So down and left. So we've got to do that same thing. We've got to go down 18 more and left 12 to get to the other end. Otherwise, we're not in the middle. And sometimes it's helpful if you put this here. So 7 minus 18,
11,
negative 11. 2 minus 12, negative 10. So our suspicions were correct that it was down here, both negative, kind of far down in that third quadrant. So our coordinates of A are negative 10, negative 11. Definitely the faster way if you have whole numbers. Again, if you're doing the formula, we know the midpoint, so that is 2. We know A, that's 14. And then we're just going to multiply by 2 on both sides. Subtract 14. And we'll get, move that down. We'll get x equals negative 10. And then same idea for y. In fact, this time I'm just going to plug it in. Okay, so it's 7, and then y b plus 25, ya this time. Multiply by 2, notice that that step is the same, because it's always going to be divided by 2. So negative 11 for ya. Did anybody do it that way, the formula way? Okay, cool. Good job. Nice. So you'll get some practice on midpoint. Let's talk about distance now. So if I say distance between 2 points, we're still on a coordinate grid. We're still talking about coordinate pairs, xy coordinate pairs, that kind of thing. If it's horizontal or if it's vertical, it's super easy to figure out. You just count boxes or subtract. For example, this coordinate is at 6 and negative 8. And this one is at negative 6, negative 2. Just haven't said this yet, but remember that x comes first, xy. So how far apart are these 2 points? The horizontal distance between these two. Yeah, we just go from negative 6 to positive 6, so that's 12. And then same thing vertically, we go from negative 2 to negative 8, so how far apart are those? 6. Those are 6, okay? Notice I'm not writing sign this time because I'm asking how far they are, not what direction. Direction isn't important. Okay, as soon as I ask you this distance, now what do? Because now it's diagonal. We can't just count boxes. We can't just subtract. So how do you find that distance? You guys remember the Pythagorean theorem? Anybody know that? Okay. So this makes a right triangle. And anytime you have a right triangle, the side lengths, so if we call this side A, we usually use A and B. Then A squared plus B squared equals c squared. So it equals the long diagonal length squared. Does that look familiar? I feel like you probably learned that in middle school, maybe. That's the Pythagorean theorem. It's relating the side lengths, sort of, to in a triangle. Guys, all we're going to do is use that. Only we're going to modify it for being able to plug in points and then solve however we want to. So in your note packet, let's go write the distance formula. And it doesn't really have the twists that this midpoint has. Sometimes your problem will ask for the length of a line instead of the distance, so just make sure you're reading it as the same thing. So we're going to kind of draw the same idea of a graph here, but this time we don't care about what's in the middle. We just care about the two end points of the length. And of course we know that both of these will have coordinates, right? So this will be xa, ya, that's the coordinates of that point. And then xb, yb, the coordinates of that point. It looks like an X. Let me fix that. Okay, so 2 points, each one has an xy coordinate. So our distance formula, again, it's just going to think through the idea of making this a triangle and using the Pythagorean theorem. Here's how that looks. So subtract your coordinates, square them, add them, square root. So a lot of little details in terms of order of operations, but the concept it makes sense if you know the Pythagorean theorem. So again, xb minus xa, that is this distance. In fact, I'm going to show that. This is xb minus xa. So just the distance horizontally. And then this distance is yb minus ya. That's the vertical distance. If we square them and add them together, like we're doing in here, then we have to square root. That'll give us the distance. So this is one you want to box and know pretty well. I will tell you that students don't usually mess up the formula, they mess up the arithmetic steps to solve in it, okay? Meaning they square wrong or they subtract wrong, those little tiny details. Otherwise, this concept isn't really that big a deal. So I'll show you what I mean, but just be careful with your arithmetic. Everybody got it? Again, this is where a calculator is very helpful. So if we want to know the length of the green line, you start with writing the formula as usual. Do you think it's worth writing that out every time? It took me about 5 or 6 seconds to write it. I definitely think so, because it tells you exactly where to plug stuff in. Okay, these ones are going to look a lot like order of operations problems, where they start kind of long and then they just kind of narrow down as you go. So, what is xb?
6.
It's this point, right? xb. So, in fact, it's sometimes helpful for students even to just go label those. xa, ya. Okay? So xb is 6 minus, what is xa?
-6.
Negative 6. Negative 6 squared. Don't forget your squared. Don't forget your minus. Don't forget your parentheses. All of those things are critical. Okay, what is yb?
-8.
It's the y coordinate of the second point, -8. YA.
-2.
Okay, be careful with your negatives. There's a lot in there. Okay. Now we just work it like an order of operations problem. We are done with the geometry. Almost we were done when we wrote the formula now. Don't drop your square root. Don't drop your parentheses. I'll write that actually up here. Don't drop the square root or parentheses. I promise that's what students mess up. And it's not a thing you should mess up. What is 6 minus -6? If you don't know that, like right away, please do it on a calculator, because that is for sure one place students mess up, is these subtractions. 6 minus -6 is not 0, but 12. Again, notice I am not dropping the parentheses. Don't do it. Your calculator will fool you if you do. Okay, how about -8 minus -2?
6, -6.
Again, if you don't know that right off, do it on a calculator. So this is -6. Okay? Notice our problem is getting shorter, right? It's decreasing in size, if you want to say it that way. Okay, well 12 squared is 144. This is where people mess up, surprisingly. Here's why. They take it to their calculator and they do this. -6 squared. Oh, that is -36. Can I have a negative distance? Is that a thing? Keep in mind that length is this length right here. Right? That can't be negative, right? So if you put it in parentheses, it does what you want it to. So it's positive. Leave it positive. When you square something, it should not be negative. So plus 36. Alright, and then continuing, this is, what is this, 180 I think? Is the square root of 180 a pretty nice number? Oh, it's ugly. So I don't want ugly decimals. In fact, some of your problems will even say that. That keeps going on forever. We don't want ugly decimals, so at this point you can leave it there, like that. Or I'm going to let you attempt to simplify it. Yesterday we talked about that. Like what goes into 180 that's square rootable. That's square rootable nicely. Any thoughts? Like does 4 go in there? Sure. Square root of 4 times what? Times 45. Is there anything in 45 that's square rootable? Nicely square rootable. Yeah? 9 is. Okay, is there anything in 5 that's square rootable nicely? No. Okay, so now we just square root the two pretty ones. 2 times 3 root 5. So this is 6 root 5. That is the preferred method, preferred answer for geometry. So I do want you trying this. That's the distance formula. Okay? Just plug and chug. Guys, when you have a formula, there's really no reason to make a big deal out of it. Plug numbers in, solve. You can even use your calculator if you're careful. So let me have you try one. And got all that. Got all that. Don't know if you can see this one. So I'm going to write the coordinates so you can see them. And so go ahead and try. This is 1, -2, and -5, 5. Go ahead and find the length of that line, please. Alright, so I've labeled these points A and B. Do you think it matters if I reversed those and called it B and A for this? Does it matter? Actually, not at all. So no pressure on picking which one is which. Alright, so xb is 1 minus xa, which is negative 5. There's one of those double negatives that seem to get students, so be careful. Okay, yb is negative 2, and ya is 5. So negative 2 minus 5. Okay, again, calculator this if you're worried about messing it up. 1 minus negative 5 is 6. Leave it in parentheses. Over here, negative 2 minus 5, negative 7. Leave it in parentheses. And then type it into your calculator exactly how you're writing it. In other words, negative 7 in parentheses squared. Okay, 6 squared is 36. Negative 7 squared is 49. Don't drop the square root, don't drop the parentheses. I should say don't drop the parentheses until you square. Then it's okay too. Now this is 85, so 36 plus 49 is 85. And I don't know if you read up here, but it says round your answer to the nearest tenth, which means it's okay to go ahead and hit the square root button on this one. So square root of 85. And you'll get 9.2 to the nearest 10th. 9.2 for that. How'd you do? Distance formula. There's not going to be any twists with this. Like, we're not going to flip-flop it where you have to solve for d. So just be able to follow that order of operations nicely through, and I think you'll be okay. But it does demand that you have a calculator. And when we get to the quiz next week, should get to it next week, if you don't have a calculator, you won't be able to do this, or at least maybe not all the way. So please get a calculator. I do still have some rental forms available if you need one. Also, I don't allow sharing, so don't plan on that either.